Good morning, students. Our today's topic in the topic of Newton's laws of motion is weight in the subject of mechanics A levels. So concentrate yourself. We are going to start now. So weight. Consider an object of the mass mkg falling freely under gravity with an acceleration g meter per second square. So m, that is kg, is falling freely under the acceleration of gravity. So weight will be w. We know that the force producing the acceleration is the weight w newton of the object. So using F is equal to ma gives w is equal to mg. That is, a body of the mass m kilograms has a weight of mg newtons. For example, taking the value of the g as 10, the weight w newton of a person whose mass is 55 kg is given by, the formula is w is equal to mg and g's value is 10. So m is 55. So 55 will be placed at the place of the m. G is 10. So 55 into 10 will be equal to 550. Therefore, the person's weight is 550 Newton because Newton is the unit of the weight. Okay, and other example is here. If the weight of a stone is 1078 Newton, now look, weight is given, its mass m kg is given by, because the formula is w is equal to mg and we want m to find out, so m will remain here and g will come to the denominator of the w. Now putting values, w is given 1078 and g's value is 10. So solving it on the calculator, you will get the answer 107.8 because kg, kilogram, is the unit of the mass. So 107.8 kg. So this is rounding off to 3 sig fig. You can get an idea of what a Newton is like if you think of the weight of a small apple. Okay, moving further, here is a question that will make your concepts more clear, how to solve the questions. So look now, a rope with a bucket attached to the end is used to raise water from a well. The mass of the empty bucket is 1.2 kg and it can raise 10 kg of the water when full. Taking G as 10, find the tension in the rope when A part is the empty bucket is lowered with an acceleration of 2 meter per second square. So in A part, the bucket is lowered. So it means the weight of the bucket will be greater than the force which is in the rope. So look now, using the weight of the bucket is 1.2 kg. So multiplying with it with 10. So 1.2 into 10 will be the weight of the bucket because the formula is w is equal to mg. M is 1.2 and g is 10. So that's why 1.2 into 10 will be equal to 12 Newton. Okay, now the resultant force downward is because the bucket is lowering into the well, so it means the weight of the bucket is more than the force that tension in the rope. So it means 1.2 g minus t because bucket is lowering. So using the formula F is equal to ma, now the resultant force is 1.2 into 10 minus t. So this is the resultant force, and on the right hand side mass is 1.2 and into acceleration is 2. So this minus t will be shifted to right hand side and 1.2 into 2 will be shifted to left hand side. So solving it on the calculator, you will get the answer 9.6 Newton. So this is the tension in the rope when the bucket is lowering into the well with an acceleration of 2 meter per second square. The B part is the full bucket is raised with an acceleration of 0.3 meter per second square. So look now, the empty bucket's mass is 1.2 kg and when full it can raise 10 kg of the water. So it means the total mass when full will be 11.2 kg, and now it is raised with an acceleration of 0.3 meter per second square. The requirement is the tension in the rope. So to raise the water from the well, it means the tension in the rope should be greater than the mass of the container. So look now, because the mass of the container is now 11.2, because the empty container is 1.2 kg and the water's mass is 10 kg, so in total 11.2 kg is the weight or mass of the container now. So because the acceleration of the full bucket is upwards, so the resultant force acts upwards. So the weight of the full bucket is now 11.2 into 10. So because the bucket is now moving upward, so that's why the tension in the rope should be greater than the weight of the container. So T minus 11.2 G Newton is the resultant force. Again, using the formula F is equal to ma, because the resultant force is T minus 11.2 into G, that is 10, is equal to M. M is now 11.2 into acceleration of upward motion is 0.3. So solving it from here, you will get the answer. So solve it on the calculator, you will get answer this one. So again, up to 3 sig fig, the answer will be 115 Newton. So this is the tension in the rope when the container is moving upward. Here is a question now. So concentrate yourself. A crate of mass 750 kg can be raised and lowered by a cable of the crane. The maximum load the crate can hold is 1000 kg. Find the tension in the cable when raising the fully loaded crate with an acceleration of 0.5 meter per second square. So fully loaded crate, it means the total mass of the crate at that time when it is fully loaded. So the mass of the crate is 750 and it can hold a maximum load of 1000 kg. So it means total mass of the fully loaded container will be 1750 kg. So look now, this is the total mass of the container, and in A part it is required that find the tension in the cable when raising the fully loaded crate with an acceleration of 0.5 meter per second square. So when the crate is raising upward, so it means the tension in the rope should be greater than the total mass of the container. So that will be the resultant force is equal to MA, and M will be this one, and A is definitely G, that is the 10. So this will be the concept of first part. So look at the second part, lowering the empty crate with an acceleration of 0.75 meter per second square. So definitely when it is lowered, so it means the mass of the container will be greater than the tension in the rope. So 750 G minus T will be equal to MA, and M will be this one and G will be 10. So this is the concept for the second part. So come to the board now. We will solve this question on the board now. So in question number 6, first part, the mass of the fully loaded crate is 1750 kg and the acceleration is 0.5 meter per second square. Now because the crate is raising, so it means the tension in the rope should be greater than the weight of the loaded crate. So this is the resultant force should be equal to MA. So T is going to be required. W is 1750 into 10 is equal to MA. M is 1750 and into A is 0.5. So solving it on the calculator now. So this factor will go to the right side and will be added in this factor. So T is equal to 1750 multiplied by 0.5 plus 17500, and this is 18375, and the unit will be Newton. Okay, in second part, lowering the empty crate whose mass is 750 kilogram with an acceleration of 0.75 meter per second square. So because the crate is lowering, so it means the weight of the crate now will be greater than the tension in the rope. So W is greater than the tension. So W minus T will be the resultant force, should be equal to MA. So W is equal to mg. So M is 750 multiplied by 10. This minus T will be remain as it is. M is 750 and A is 0.75. So now this vector will go to the right hand side and this vector will go to the left hand side and will be subtracted from this vector. So solving it on the calculator. So 7500 minus 750 into 0.75. The answer is 69375. 69375, and the unit will be Newton. So this is the answer of the second part. Here is another question. So look at this statement. Question number 7. A balloon of mass 1400 kg that is given is descending vertically with an acceleration of 2 meter per second square. So descending vertically, so it means it is moving downward. Find the magnitude of the air resistance acting on the balloon. So because the balloon is descending, so it means the weight of the total container will be greater than the air resistance F. So that will be the resultant force which will be acted on the balloon. So 1400 G minus F will be the resultant force is equal to MA, and M will be 1400 kg, and A, definitely the acceleration of the gravity will be applied, that is 10. So 1400 G minus F is equal to 1400 into 10. So this will be the concept that will be used in this question. So come to the board now. We will solve this question on the board now. So in question number 7, a balloon of mass 1400 kg is descending with an acceleration of 2 meter per second square. Find the air resistance. Because the balloon is descending, so it means the weight of the balloon will be greater than the air resistance. So weight is greater than the air resistance. So this is the resultant force, should be equal to MA, and W will be equal to mg. So 1400, and because in this case the balloon is free falling, so G will be 10. Air resistance is the requirement. M is 1400 and A is 2. So this R will go to the right hand side and this vector will go to the left hand side and will be subtracted from this vector. So solving it on the calculator now. So 14,000 minus 2800. So the answer is 11,200. So this is the air resistance that will be applied on the balloon whose mass is 1400 kg and which is descending with an acceleration of 2 meter per second square. Here is another question, that is question number 8. So look at this statement. A block of the mass 4 kg is lying on the floor of an elevator. So here is the block of the mass 4 kg that is placed on the floor of the elevator that is accelerating at 5 meter per second square. So this is the acceleration. Find the normal reaction exerted on the block by the elevator floor if the elevator is A part going up and B part going down. So concentrate yourself. The concept for going up and going down will be, so if the if something is going down, so it means the mass of the object will be greater than the reaction, will be equal to ma. So actually the resultant force matters. So first you have to understand what is resultant force. So if the object is going down, so it means the mass of the block object will be greater than the reaction. So this is the resultant force, because formula will be used, F is equal to ma. So now this resultant force will be applied in place of the F. And the mass is given, that is 4 kg. A is definitely 10 meter, or A is given, that is because this is not free falling, so acceleration is 5 meter per second, that will be used. And if the object is moving up, so it means the reaction will be greater than the mass or the weight of the object. So F minus W, that will be the resultant force. Now that will be put in place of the F, will be equal to ma. M is given 4 and A is 5 meter per second square. So this is the concept that will be used in this question. So come to the board now. We will solve it on the board. Okay, in question number 8, the mass is 4 kilogram and the acceleration is 5 meter per second square. So this type of the figure is given in question. So this is 4 kilogram mass and the acceleration is 5 meter per second square. In first part, the body is going up. So for going up, definitely the tension in the string will be more than the weight of the body. So T minus W will be the resultant force, will be equal to MA. Tension is the requirement. Weight is 4 multiplied by 10, because W is equal to mg, is equal to M, that is 4, into A is 5. Okay, from here, this factor will go to the right hand side. So 20 plus 40 will be equal to 60 Newton is the tension in the string when the container is going up. In second part, it is given that the container is going down. So when going down, it means the weight will be greater than the tension in the string. So this will be the resultant force, will be equal to MA. W is equal to mg. So 4 into 10 minus T is equal to 4 into 5. This T will go to the right hand side and this will be 40. This 20 will come to the left hand side. So T is equal to 20 Newton. So this is the tension in this string that will be when the body will going down.